Determine whether the infinite geometric series is convergent or divergent. If it's convergent, find its sum. Now remember, if r, or my common ratio, is less than 1, it will converge, and we can find its sum. If r is bigger than or equal to 1, then it's divergent, and we won't be able to find it because divergent means it's going to go off to infinity. So we need to find r first in this case. R is going to be one term, and I'm going to use 4/25 and divide it by the last term before that, which is 2/5. Flip and multiply. This reduces with this to become a 5. This reduces to this to become a 2, and I end up getting 2/5. So my R looks like it's going to be 2/5. Let's double check and make sure it actually is 2/5. If I take 8 over 125 and I divide it by 4 over 25, flip and multiply. 4 divided by 8 is 2. 25 divided by 125 is 5, and I end up getting 2/5 once again. So yes, 2/5 is R. Now, 2/5 is less than 1 because the top is smaller than the bottom. So since it is less than 1, it will converge. So this will be convergent. So this means I can find its sum. So I'm actually going to write this as a summation. So this is going to be the summation from n equals 1. Now we're going to go off to infinity. We don't have to find an nth term. Of 2 to the 5th, 2/5. That's my first term. We know that an infinite geometric series is going to look like this. A, and then it's going to be r to the n minus 1. So this is going to be 2/5 to the n minus 1. So I also know that my infinite sum is going to equal A divided by 1 minus r. So A is going to be 2/5 divided by 1 minus 2/5. So then we get 2/5 divided by, if I get a common denominator, 5/5 minus 2/5. Or in other words, 2/5 divided by 3/5. That's a 3. Flip and multiply. This reduces with this, and we end up getting 2/3. So that is what it's going to add up to be.